Hello boys and girls. For this video lesson on equivalent expressions and equations, you will need some scratch paper. Eventually you're going to, when I ask you to and give you some type of signal, you're going to pause the video and perform a little bit of work. You'll need some scratch paper and a writing tool to do that, of course. Take a look at these two samples here, or these examples, example A and example B. Can you explain why in example A the yellow highlighted expression is equivalent to the green highlighted expression? And in example B, can you explain why what's highlighted in yellow, that expression, can you explain why it's equivalent to the expression highlighted in green? What I'm asking you to do is explain why the expressions in yellow are equivalent to the expressions in green. We've studied equivalence as being equal. Why is that? I'll give you a signal. I'll say something like go, and that's going to be a signal for you to pause your video. And what I'd like you to do on a scratch paper is I'd like you to perform some type of action. You can copy these problems down, but I'd like you to perform an action that makes the yellow highlighted expression equal to the green highlighted expression. Again, on your scratch paper, I'd like you to perform some type of action that makes the yellow highlighted expression equal to the green highlighted expression. Okay, so in a few moments I'll say go, and then you can try to perform that action to make the yellow highlighted expression in sample A equal or equivalent to the green highlighted expression in sample A, and the same thing for B. Make the yellow highlighted expression in sample B equivalent to the green highlighted expression. Do something on that paper to make that happen. Go. Okay, well, I'm back. Hopefully you paused that video and tried that out. If you haven't done that and missed that cue, pause it right now and do what I've just said. Otherwise, right now I'm going to explain the action that makes the highlighted yellow expression equivalent to the highlighted green expression. It's called the distributive property. And you see the word distribute in here, or the root distribute is in here. And I want to show you how I use the distributive property to make an equivalent expression. I'm going to take the expression that's highlighted in yellow, and I'm going to create its equivalent. And I'll write an equivalent expression using the distributive property. There will be something distributed, and I want you to try to notice what that is and compare what you've done on your paper with what I'm about to do. Okay? Because it may or may not be similar. So this is a great chance for you to compare your thinking with your teacher's thinking before you even get to class and compare yours with your classmates. Okay, so I'm going to take the expression 3 and then in parentheses x plus 3, and I'm going to write an equivalent expression for it using the distributive property. The distributive property tells us to distribute something, and what we're going to be distributing is multiplication. When you have your constant, when you have this term, it's called a constant, touching a parentheses, what you're instructed to do then is multiply this constant by everything in the parentheses, like this. 3 and x would multiply together, so you would have 3x. So the 3 constant and the variable x, when they're multiplied using the distributive property, become 3x. We know to multiply them because we have the parentheses over here touching or right next to the 3. We're going to copy down the plus sign because we're using the operation of addition, and then we're going to multiply 3 by whatever's inside the parentheses, 3. 3 times 3 is 9. So now, you can see in sample A, the expression 3 parentheses x plus 3, close parentheses, is actually equivalent to 3x plus 9. Let's take a look at this one. If you didn't do that in your action on your paper, you may want to try it right now. You may want to pause the video and actually try this distribution of multiplication with the number outside the parentheses with whatever's in the parentheses. Go ahead and pause it if you want to do that right now. Otherwise, I'm going to continue showing you. So I have 6, which is my constant term. It's outside the parentheses. In the parentheses, we've got x squared plus y plus 2, close parentheses. Because these are touching, this is a signal now to multiply. I'm going to multiply 6 on the outside with whatever's on the inside. 6 times x squared is going to be 6x squared. I have my coefficient now. I'm going to copy the operation sign, plus. Now I'm going to do 6 times y. You can see the multiplication being distributed across the parentheses. 6 times y is 6y. And finally, or not finally, but I'm going to add that addition sign there, because that's what we're going to copy. 6 times 2 now, to finalize it, is 12. What I've done now is I've created an equivalent expression for originally what's highlighted in yellow, 6 parentheses x squared plus y plus 2, close parentheses, is equivalent to 6 squared plus 6y plus 12. These are the same expressions. I want to let you know, if you want to take a break, it's an okay time to do it. We got about 3 or 4 minutes left in the video lesson. Feel free to take a break right now, come back. We're going to go to something else, okay? I'm going to continue, but if you need to take a break, the rest of the lesson lasts another 4 or 5 minutes. Okay. I'm moving on to the next part. This is something we're going to study in class. If you need help, of course, you'll see me. You know, you'll take a survey, which allows you to practice this some more, but you'll have some practice, opportunity to practice this in class on Monday and Tuesday. Take a look at this. What do you see over here? You see an expression, right? You see 3y plus 10, am I right? That's what you see, 3y plus 10. What is it? Well, you know what it is. It's an expression. Okay? Well, what is this? Did you say an expression? That's true. That's what it is. This is an expression too. Okay, so we have 2 expressions. We've studied expressions. 3y plus 10 and 7y minus 6. All right. These are algebraic expressions. They're not numerical. They have a variable in them. Watch what I'm going to do now. Now what do we have? Do you know what we have now? Before we just had 2 expressions. And now I put an equal sign between the 2 of them. We have right now what's called an equation. We have this expression being equal to this expression. These are not like equivalent expressions. All we have is an equation. This, boys and girls, is called a one-variable equation. You might see 2 letter y's, but we have one kind of variable, and that's the letter y. So, what does this mean? I'm going to read this to you, and on Monday and Tuesday we'll have time to practice solving this. Because you have an equal sign here, this is implying that you have to solve for the letter y. Y has some value. Algebra is solving for an unknown or a missing value. What we have to do then is solve for the unknown or missing value. We need to find out what y is equal to. Well, here's what this equation states. It states 3 times some number plus 10 is equal to 7 times that same number minus 6. So what is that number? There's one number in the universe that when you multiply it by 3 and add 10, it equals the same thing as when you multiply it by 7 and then subtract 6. There's a way to solve this problem. You're going to be learning that on Monday and Tuesday. Take a look at the parts of an equation. What we have here are all the parts of an equation. We have the coefficient, 3y. We have the unknown term, y. We have our operation symbol. We have a constant. We have another coefficient. We have another operation symbol, the subtraction sign. We have a constant. Y is the unknown term. Perhaps the most important thing, you can't have this equation unless you have this equal sign. Again, what this is saying is 3 times some number plus 10 is equal to 7 times that same number minus 6. There's a way to solve this. Hey, if you want, put this video on pause and tell me what y is equal to then. because we'll be learning that on Monday and Tuesday and, throughout the year. What I'm going to do right now as I finish this lesson up is I'm going to solve this for you. And then I'm going to pose a problem for you to solve. So the lesson's going to wrap up in about 2 minutes. What you're going to see next, and if you need to take a break, take a break. But what you're going to see next is me solving this equation. I'll tell you what y is, and then I'll give you one to solve. I'm going to go back up here to do my solution and my solving. 3y plus 10 is equal to 7y minus 6. Y has some value. Well, these are some important words or essential vocabulary or even phrases that I think are going to be really important for you to know or to use and to refer to when studying how to solve an equation. Terms, coefficients, variables, constants, like terms. These 5, 6, 7, and 8 you haven't really been exposed to so much. Like terms, combining like terms, balancing and isolating. I'm going to do all of this. This is the language that I'm going to be using next week. Alright, let me push this up here a little bit and push this down, and I'll begin my solving process. Okay, and then I have on slide 4 one for you to solve, and you can solve one on the survey too. Here we go. 3y plus 10 is equal to 7y minus 6. So, I have terms in here. I have, let's see, what kind of terms do I have? I've got constants, and I've got coefficients. Those are the two different kinds of terms that you would have in any equation. I got my coefficients, and then I got my constants. Okay, just those are the terms I have. Alright, I'm going to erase that. Just wanted to identify them. Here is a coefficient, there's a coefficient, and here's a constant, here's a constant. These y's are represented as variables. They're the unknowns. Okay, so the first thing I want to check to see if I can combine any terms. Let's see, can I combine anything? I want to look to see if there's something on one side of the equal sign that I can combine. I'm going to focus on this part of the equal sign, the left-hand side of the equal sign. Anything that I can combine? Absolutely not. I cannot. There's no like terms here. We can only combine terms that are like. You cannot combine a coefficient with a constant. You cannot combine them. I'm sorry, you can't. Let's take a look on the right side of the equal sign. We've got 7y minus 6. Can I combine anything here? I can't. 7y can't be subtracted from 6. 6 can't be subtracted from 7y. If there was another y on this side or another constant on this side, I could put them together. But there's no combining of like terms because on either side of the equal sign there are no like terms. Same thing with this. If there was another y here, if there was an 8y or a 2y or just another y, or I could combine that with this 3y. If there was a 4 or a 5 or a 9, I can combine that with a 10. There's no combining like terms here. So what I'm going to start doing now is the balancing. I'm going to start balancing this out. I want to keep my constants on the left side and my coefficients on the right. Okay? Or maybe I want to do it the other way, but let me try this out. I'm gonna try to keep all my constants on this side and coefficients on the right. So I'm gonna get rid of 3y from here. Okay. If whatever I do on this side, I have to balance with on this side. This leaves me with 10 is equal to 4y minus 6. Okay. Let's see. 10 is equal to 4y minus 6. If I take away 4y from this side, because, well, I only want to keep, I want to keep my constants on this side, my coefficients on this side. Notice I've got a constant here. It's a minus 6. So what I want to do is, I want to get rid of this constant. I'm going to add 6 to this to get rid of it. I'm going to add 6 over here because I have to balance it. The reason I'm getting rid of this, the reason I'm focusing on the 6 is because I want to keep the coefficient on this side, and I want to keep the constants on this side. So to get rid of the 6, I've got to add it, because minus 6 and plus 6 cancel out. It's the inverse, so I'm going to get rid of this now, and what I'm left with is 16 is equal to 4y, or 4 times y. Now I'm going to do the inverse. I'm going to isolate my variable. 4 times y, or 16 is equal to 4 times y. So I've got to do some isolating. How can I get y to be by itself? This is 4 times y, so I've got to divide 4y by 4. And 16 divided by 4 is 4. So y is equal to 4. Here's the one that you can try. 2k plus 17 is equal to 9k minus 4. Try this one out. Thanks.